There are a couple of different ways that you can fade values over time on a Medialon timeline. And a lot of that depends on what device type you're using and what the command set available for that device is. So if we use a Medialon DMX 512 device, if we use a set levels out command, you'll see that there's a fade time variable in that. So we can take that, drag and drop it into the timeline, and maybe at the beginning of it, we'll just do a blackout. So we're going to set channels 1 through 512 at 0 with a 0 count. So we know that we're starting from a blackout. Then after that, we're going to drop in, I'm just going to do channel 1 through channel 1, and I'm going to take that to 127, halfway. And I'm going to do that in a 4 count. So now when I run my timeline, the output is going to ramp up from 0 to 127 over 4 seconds on channel 1. I've already set up this MXM to also be listening to DMX on the same universe, so it's going to have variables associated with each of the channels. Let me just expand this a little bit so we can see that. So channel 1 is going to be affected by this. So if we run this timeline, so we'll go into debug mode and run the timeline, you're going to see that the variable starts ramping up and it takes 4 seconds to get to the value 127. So there's a notion of positrack, position tracking in Medialon that allows you to jump around in the show, and it will tell all of the devices controlled by the timeline to go to what they should be doing at that moment in the show. So in this case, it's mid-fade. It's jumping that DMX value to 46. But if we jump back a little bit, it's going to 21. If we come over here, past the end of the 4 seconds, that's going to be at 127. So this is for every device that's controlled by a timeline. But what do you do about devices that don't have commands with fade times? Well, there are abstractions that you can use. So if we use an OSC device here, OSC just has a send value command. There's no notion of timing or anything else like that, but that doesn't mean that we can't achieve it. So what we're going to do here is take the send value command and trigger that whenever the slider moves. And then we're going to use the variables management device to fade the value of the slider over time, because the variables management has a command that allows you to use a fade time. So we're going to use the OSC command send value when the slider changes. So then slider changes, I want to send to the address, and I just set this up as integer. And we're going to use the value coming from the slider. Status, okay. And we're going to send that as an integer. So now I've also set up a variable to monitor that. So if we go into debug mode and I move that slider, oops, I got a command failed. I must have spelled something wrong here. Let me check the send value. Oh, I didn't type in the address, /integer. Try that again when I move that. Yeah, so now I'm getting the value of the slider here being sent to the path, the address integer, as an integer whenever this slider moves. So now if I programmatically move the slider in my timeline, you're going to see that moving in you're going to see the slider move, but you're also going to see the value that's being sent over OSC moving as well. So in order to do that, we'll use the variables management MXM to have a device, and we're going to use the start counter command. So I'm going to drop that in on the timeline, and I'm going to tell it what integer variable I want to affect. It's going to be that slider status, and we're going to go from the value whatever to the value whatever. So we'll go from whatever its current value is. So I can just ignore the initial value. And we're going to say the final value is going to be whatever we say. So maybe I want to fade this up to 80. And then I can choose whether I want to use an incremental value or a time. So I'm going to fade that over a period of 6 seconds. and I'm going to start from the current value, so wherever it's at right now, and use the duration parameter here of 6 seconds to define that ramp. So now we'll go ahead and run the timeline, and as that's going, that command executes and it starts a 6-second fade of that value from wherever it was to 80 to the value 80. So now we're already at 80. What if we're at, let's say, where are we here? At 32 when we run that. Okay. So it just picks it up from there, and it still takes 6 seconds to get from 32 to 80 because it's starting from its current position rather than starting from a known value. If you go back and modify that command, we could say always start from the initial value, and if I set my initial value to 10, even if my current value is 33, when we run through that, let me just set that again. So we have, say, 34, and run through that. It snaps back to 10 because I told that command to begin at the initial value, which was set to 10. So to avoid that, if you just want to track forward, you would use current value. So if I'm here and I play through, it's going to take 6 seconds to get from where I was to my target value, 80. And that's where we are. So these are all linear moves. If you want to do a curved ease in, ease out kind of a move, you're going to need to add additional logic that basically calculates the Bezier curve, and you can use a function to do that. And basically the way you do that is you create a user variable to contain the in-between, and you use the variables management to basically calculate the fade from 0 to 100 or 0 to 10,000. Depends on the granularity you need. And then you use that 0 to 10,000 variable as the basis for the calculation that determines the ramp. And then you would use a kind of Bezier trigonometry curve, something like that, in order to smooth out the beginning and the end of that move. But it's basically using the same tools. You would use variables management and the start counter command to affect a linear fade of a reference variable that's referencing basically where you are along that curve, and then use an expression that calculates based on a change of that variable. It uses that variable to figure out what the result of the curve function would be, and then that gets dumped into another variable in the system, like a user variable, or maybe even another slider or a gauge or something, and that comes up as the thing that then triggers or gets sent to the device. So if we're going to do that, let's go ahead and I'll go ahead and create a gauge here. So I'll do a gauge, and this slider goes from 0 to 100, so that's what we'll use. 0 to 100 also on the gauge, but we want to smooth out the bottom and the top on this. So when this value changes, okay, right now we're sending directly to OSC, so I'm going to get rid of that. And I'm going to do an expression calculation. So I need to first calculate, I need a real value because this is all based on some floating point math. So we're going to say real input. So my real input is going to be taking its value from the value of the slider. Oops. So I'm going to pull the value of that slider. Oops. say my real input is going to take its value from the slider divided by the entire range of the slider, which was 100. But in order to cast this as a real, we need to multiply by 1.0 times the slider. Or we could do 0.0 plus the slider. Basically what we're doing is saying the first item after the equal sign determines the type of the variable. So we're going to do math in the real realm here. So we're going to divide the slider by 100. To be safe, you could do 0.0. So now we're setting our real, and then we can calculate an output real. So we'll do a real output. So my real output is going to take the value of whatever the input was. So we'll do my real input squared. This is the formula that you use. Squared times real input uh, 2 times real input times, no, 3.0, so times 3.0 minus 2.0 times the real input. So real input squared times 3.0 minus 2.0 times the real input. That's the calculation for a Bezier curve. So we'll use that, and what you're going to end up seeing here is as we move that slider, I'm moving somewhere between 0 and 1. So I got 0 on the far left, and I have 1 on the far right. But you're going to notice that in this lower range, even though my my source is at 0.07, my output's only at 0.01. That's because of that curving on the low end, and then it speeds up until you get to 50%, and then actually the output goes faster than the input up until you get to around 85-90%, and then the output starts slowing down until you get to 1. So that's a way of easing in and easing out using a Bezier curve. Now we got to get that real output. This is basically a percentage of the value that you want to send back into the range of 0 to 100. So we just need to multiply that by 100. So we're going to take our output, which is our gauge here. So I'm going to take my gauge status, and it's going to take the value of the real output. But we're going to do an integer out of that, so we're going to do 100 times the real output, and that's going to give us our gauge status. So now we can go ahead and play with that, and you'll see what I was talking about as I move up the, oops, I did something wrong. The status equals, oh, yeah, maybe I should do real output times 100, because it's going to do the floating point math and then convert it to an integer if you do it that way, which is what you want. Otherwise, you're only going to get a 0 or a 1, or a 0 or a 100. So you'll see that we are not even with each other, but as we approach 50, now we're even with each other, and now this gauge is going to go ahead of us, and then it's going to slow down, and this last little bit takes the easing on the top end. So that's your Bezier curve, and that's how you would achieve that. And then you can attach to whatever your output is when this value changes. So when that variable changes, that's when we want to send our value. So we're going to send that to /integer. I'm going to take the value from that gauge status and send it as an integer. So now, on our timeline, when we move that integer from wherever it's at to 80, you're going to be curving along that line. So there's one additional step that we didn't get into in this video, and it's a little outside the scope, but of this is treating a curve of the entire range. So that would be something like if you needed to make an adjustment based on the responsiveness of LED lighting fixtures, and you wanted to maybe do an amber shift on a couple of the colors or something, you could treat that across the entire range. That's the calculation that we just did. If you need to tween between values on there and ease in and out of values within there, there's another calculation that you can do. It's basically taking the difference between the values and calculating the percentage of the distance that you've gone between those values and adding on the bottom value. But it's basically the same principle. So I hope this was helpful. And if you have any questions, please give me a call.